So okay, let's start with the explanation of this program equation. So 0 1, that will be a basic for Fibonacci, then again 1, then 2. How 1 comes? So addition of this 0 and 1. How to come? Addition of this 1 and 1. How, what will be come next? So 2 plus 1, that will be 3. What will be the next? 3 plus 2, that will be 5. And what will be the next? 3 plus 5, that will be 8, and so on. So this is what our logic is, and this is what our this is what we need to achieve through the our programming. Okay, so what we came to know that previous 2 digit will be needed for finding a next number. Okay, so let's initiate the class name as solution. Okay, I'll give it here, and okay, and okay, in class we can declare public. So what is needed to return, that will be the, so yeah, we need to find out the Fibonacci series. We need to find out the addition of the Fibonacci series. So what will be the return type? That will be integer, because what is expected to return an addition of all the Fibonacci number. Public int public int fib Fibonacci series, and it will be taking an input n integer, as it is stated over here. N will be the n input. Okay, so public int fib, that will be our function definition. Why int? Because we are returning an integer number. Okay, so return, what we can say, we can either say a Fibonacci number, or we can say what is at the end. It will be a sum, so I'll declare it as a sum. Okay, so yeah, so what will be the sum? uh, Sum will be the sum is equal to previous plus previous minus 1. Okay, so let me declare this sum as 0. uh, Previous will be 1, and there will be also a previous minus 1, which will be the 0 at the end. Okay, but that won't be an perfect solution, because when we are at 5, then previous minus 1 will be 4, and that is not the case. Here it is a 3. Okay, so what we need to do, we need to find, and so that can be achieved as well, but we have one option named recursion. So if I call fib, okay, n minus 1, n is passed over here, plus fib n minus 2. Okay, just get rid of this previous. We don't need that, because it is already there. Okay, so that will be our recursive solution for this. But have we took care of edge cases, like what if number is what if n is, if n is less than 0, what should it return? It should return and error. System dot out dot println error. What will be the next edge case? So you need to explain edge cases as well. First, you need to give an, you can either think or explain about the edge cases to the interviewer after you are completing main logic, or you can discuss at the initial point of time as well, but make sure you'll discuss that. That will be give and good impression on interviewer that you are thinking about the edge cases. So when n is equal to 0, what is expected to return? It's 0. And if n is equal to 1, what is expected to return? Yes, right, return 1. So yes, this is our fulfill recursive solution for Fibonacci series. But that is, this is very basic solution. Do we have any better approach? Answer: yes, we have. Answer is dynamic programming. But there are two types of dynamic programming, two approaches to achieve an dynamic programming. One is memoization, Second one is top-down approach. Okay, sorry, so do we have a better solution instead of using a recursion, or can we optimize this recursion in any way? So yes, here dynamic programming comes into the picture. Actually, there are two types of dynamic programming approaches. One is bottom up and one is top down approach. So so top down is nothing but a memoization, and memoization is nothing but use of recursion and saving that value of the recursion in any particular variable, so that we will avoid repetitive calculation of any problem. Okay, so in recursion we are repeatedly calculating s- uh, uh, output for same input. Okay, so if we save that output, then we don't need to calculate, we don't need to get into the deeper into the recursion, and we'll simply return from there, as we already have calculated for that specific input. Okay, so let's see an memoization approach. There is nothing big in the memoization of this program. So what memoization state itself? To save the result, to saving a result, what we need to have? We need to have some variable, some array to store that variable, or store that value, right? So what we'll do, we'll create an array. Okay, I'll simply tell you how. We'll give a name as memo means memoization. Okay, that will be the, it will be having a size of n. Okay, and so this is what the memoization declaration is. And now we do not modify anything. We'll just check n is equal to 0, and if it is true, then it will return error. If n is equal to 0, it will return 0. If n is equal to 1, it will return 1. And then the same, we'll declare a sum, and we'll be calculating. A sum is not an local variable over here. Sum is declared somewhere outside of this function, as well. When you when you when you recursively call, then again it will be initialized to 0. We don't want that. We need to make sure that some value persists throughout the recursion. So yeah, I simply make it global. Okay, a global variable outside the function. Okay, but inside the class. Okay, and so yeah, sum, it will return a sum. And what we'll do, as I stated, why we declare this memo of n, okay, is equal to sum. Am I right? And so how we will avoid this? This will be again not the part in the initialization. That will be in the form of n. So I make sure that n is from the main method, and you should know while declaring the value of n while declaring the memoization. So m will be there, and sum. So m is equal to sum. So here we are saving the value. So how to avoid this all computation? By simply putting if condition memo of n is not equal to null, or memo of n is not equal to -1, then simply return memo of n from here only, instead of computing. So instead of checking everything again and calculating sum for the same input, if the, so we are storing for any number, like say 2, we are saving its sum at index 2. So whenever n will be to 2, first of all it will check if memo of 2 will be the null or -1. If yes, then it will go for calculating the sum for the memo of 2 when n is equal to 2. Rather, if no, n is equal, memo of n is equal to having some value, means it is already calculated, and it will be simply written from here. So this is nothing but and top down approach, which is also called at memoization. Okay, Memorization also an good optimized solution, but the cost of memory consider over here, and we need to know the size of array as well. It's depend on the input. So again, there is an bottom-up approach as well to solve this, which is also probably proper as an dynamic programming. So, in some cases, and there are very rare cases where memorization approach falls, but or not succeed because of exclusive use of memory. It get overlapped or overflow. So let's check and bottom-up approach of memorization. It is nothing but an iterative approach. So what is opposite to uh, uh, memorization is nothing but using an recursion. Recursion works by top to down. Okay, it from the bigger input it gets into the down in the dive. That's why it is called as top-down approach. And bottom-up approach will be exactly opposite to this approach. So what is opposite of the recursion? It's an iteration. Okay, so yeah, so we'll just check for we'll just check for and bottom up approach. So again we need an memory over here. Let's say a array will be in my memory. Okay, we'll declare. So we need to find out the base conditions. We need to initialize our TP or table with the or the simply array with base conditions. What will be the base condition? That will be come from the if condition of the recursive approach. So here we can see n is when n is equal to uh, 0, what will be the value? That will be the 0. Okay, if a will be the 1, what its value already given in the input or in the base condition, it will be the 1. Now we'll start our iteration will be starting from 2. Why? Because 0 and 1 is already computed. Okay, as per given input. So our input will be runs to n, and this is what our for loop is used for iteration. So what we'll be calling a of I will be a of I minus 1 plus a of I minus 2. Are you getting my point? So here we are recursively calling by minimizing the input by 1 and input by 2. So instead of here we are initiating our array. We are computing a of I by checking the previous value, right? And once we are done with the for loop iteration, what we need to return? We need to return a of I. I hope it's clear to you. Return a of n. Just get rid of this everything. We also need okay. So this is very simple approach where we declare and where we have shown our function for Fibonacci with the bottom-up approach. Great. So what is basic takeaway? There is an iteration solution. We can memorize by storing it into the memory. Later, we can use an bottom-up approach where also we use an array with the given input size. But we also, there is must condition that you know about the base condition, and according to that you need to initiate your table with the base condition, and later you need to calculate same as a recursive logic like I minus 1 and I minus 2, and at the end with the a of n you'll get an your answer. Why at the end we are getting answer? Because we are that is what our big value for which we are trying to calculate our Fibonacci series, and I minus 1 and I minus 2 is nothing but that's breaking up that big problem into the small chunk of the problem, and depending on the output of those problem we are getting our solution. I hope I'm clear. So I didn't draw any dynamic programming table DP table over here. I hope with the explanation you can try to understand that, and for bigger problem we'll first start with the table and I'll explain the code later. So have a nice day. Goodbye.